Hey guys, I'm back. Today we're going to talk about systems of equations using elimination. This is the final method of solving systems of equations. I think you'll find that it's a little cleaner than substitution. That got kind of messy, didn't it? So say hello to my little office assistant today. I'm starting to talk to stickers and Mr. Potato Heads, but it's all good. So I'm going to upload these notes into Teams so that you can print them out if you'd like to and fill them out while I'm going through them. Or you can just get a piece of notebook paper out and write down what's being said. Okay? So first of all, elimination. What is it? It's a method for solving a system of equations. Here's the important part: by adding or subtracting to eliminate. Okay? Adding or subtracting to eliminate a variable, the x or the y. Remember when we were doing substitution, we were solving for x or y so that we could eliminate one of those variables and substitute something else in. I think you'll see that this is, like I said, a little simpler. So here are the steps. First of all, you need to make sure that the equations are lined up. And this is a very important, if you don't do this from the start, then you're going to get really confused. And what I mean when I say to line them up, if you remember when your teachers way back when were teaching you how to add and subtract, like 787 plus 23, didn't they tell you needed to make sure to line up your ones column, your tens column, and your hundreds column? Otherwise you're going to get a different answer than everybody else. Same idea here. We're going to line them up. I'll show you how that works here in a minute. Step 2, we're going to add or subtract the equations to eliminate the variable with common coefficients. Now later, next week, we'll learn how to do it without common coefficients. But common coefficients is going to be how we're going to pick which variable gets eliminated. Step 3, we're going to solve for the remaining variable. And then step 4, substitute your answer, just like we had to with substitution. Once you got your x, you had to go get your y, or vice versa. Same thing here. Substitute your answer into either original equation and solve for the other variable. Okay, so you ready to see what that looks like? My handy assistant and I are ready to show you. So here's a system of equations. It's already lined up. I have my y's in one column, I have my x's in this column, and I have my constant numbers in this column. And I have the equal signs lined up. So now I'm ready to eliminate. Your choice is addition or subtraction. Okay, just keep it simple. Addition or subtraction. Now if I add these together, will my y's be eliminated? No, y plus y is 2y. If I add it together, will my x's be eliminated? No, 3x plus x is 4x. So I'm pretty sure I'm going to have to use subtraction. And it gets kind of tricky when you're talking about subtraction because, well, I'll tell you about it here in a minute. But it will make it easier if you put parentheses when you subtract. This tells me we're going to do y minus y. Okay, I can put my equal sign there. Y minus y is 0. 3x minus x. If I've got 3 and I take away 1, I will have 2x. Now here's where I was talking about the subtraction sign gets a little in the way because I already have a subtraction sign over here. And it's easy to say, oh, 4 minus 2. I'm subtracting, aren't I? But no, I'm subtracting a negative number. 4 minus negative 2. And subtracting a negative is the same thing as adding a positive. So that's why this is plus 6. And now I can solve for x. Subtract 6 from both sides. That will tell me that 2x is equal to negative 6, or x is equal to negative 3. Okay, remember that step where we take the variable that we just solved for and we plug it back into one of the original equations? You can pick whichever one you want. You can do y, you can plug it into the first equation, you can plug it into the second equation. I happen to like this second equation because it's a little more simplified, but it doesn't matter. So if we have y is equal to x minus 2, now I can substitute in negative 6 for that x. So y is equal to -6 minus 2. Oops, that would be a -3, wouldn't it? Let me cross that out. Y is equal to -3 minus 2. Oh, this has been a day. Okay, so what is y equal to? -5. Now you can go back and check. If I put a -5 up here and I multiply 3 times -3, which is -9, plus 4 is -5. Ignore my mistake there. Sorry about that. My assistant didn't catch it either. Oh my. Okay, let's do another example. X plus 4y equals 13 and x minus y is equal to 3. Okay, first of all, are they lined up? Bring my assistant back. Are they lined up? They are. I have x's, I have y's, I have constant numbers. I am ready to add or subtract. X plus x is 2x. 4y plus y. Well, first of all, these are not common coefficients, so I don't even need to worry about the y's. I've got to figure out, is addition or subtraction going to eliminate these x's because they have the same number in front of them, which is that unseen 1. So we're going to subtract. And I always put parentheses around to remind me that I'm subtracting. X minus x is 0. 4y minus -y turns this into a plus y. So I'll get plus 5y. And then if I do 13 minus 3, I'm going to get a 10. Now I don't need that 0 there anymore. It's not doing any good. So I could just turn this into 5y equals 10. Divide each side by 5. So y is equal to 2. Now we're going to save that 2, and we're going to plug it into one of the original equations. Y is equal to 2. Here, I don't want you to think that's a 23. Okay, y is equal to 2. Once again, I think I'm going to use this bottom equation because it's more simplified. X minus y is equal to 3. X minus 2 is equal to 3. So if I add 2 to both sides, I'll get x is equal to 5. Now you may say, what would have happened if I had put 2 into this equation up here? Well, then we would have had x plus 4 times 2 is equal to 13, or x plus 8 is equal to 13, and then if I subtract 8, we get x is equal to 5 all over again. So see, it doesn't matter which equation you use, you can pick the simpler one. So now we're going to take our x and our y and create our coordinate point, and our answer is 5, 2. Hope that makes sense. Okay, I'm going to pause this video because I don't want it to get too long to upload it. I'm going to do 2 more examples in an additional video here in just a minute. See you guys on the flip side.